power series in x is a function of x. So I have f of x equals the sum of n equals 0 to infinity of a sub n times x minus c to the nth power. The domain is all x for which the series converges. Okay, so every power series converges at its center. So all converge at their center. And why? Because you're multiplying by the center, which is x, which is c. So c minus c, which is 0. So everything except for the 0th term is going to be 0, because you have a to the 0 times c minus c to the 0 power plus a to the first times c minus c to the first plus a to the second, c minus c to the second. So these all become 0, and because of the 0 power was 1, so it just equals a naught. So when it always converges at its center and equals a naught. So my convergence of a power series theorem goes like this. So I have a power series centered at C. Okay, precisely 1 is true. The series converges only at C. Which we know it does anyway, but only at C now. There exists a real number, R, which is greater than 0, such that the series converges absolutely for x minus c less than r, and then diverges x minus c greater than r. And the third possibility, so here's a conditional, this is like a conditional convergence, and the third one, it converges absolutely for all x. Okay, so R is my radius of convergence of the power series. And if a series converges only at C, so if 1 occurs, then my radius is 0. If it converges for all x, so if 3 is true, then my radius is infinity. And then the set of all values of x for which the power series converges so the x within that radius is called the interval of convergence for that power series. So I have an interval of convergence, so that's really everything, all the x's that fall when I'm in here with my radius.